Hello and welcome to Mr. Quinn Maths. In this video we will be focusing on surds and rationalising the denominator of a fraction. This is a topic within the C1 course. Now let's have a look at this fraction. As you'll see, the denominator of this fraction is a surd. In maths we do not like to leave a surd at the bottom line of a fraction. So what we must do is rationalise the denominator of this fraction and change how this fraction is displayed. So at the bottom of our new fraction we'll have a rational number. We will use this fact at the top here to help us. So remember that root a times root a is equal to a. And also, here's an example here. Root 9 times root 9 is equal to 9. Root 16 times root 16 is equal to 16. Now we're going to use this fact to remove the surd from the bottom line of this fraction. So let's have a go with that. So we will multiply this fraction by root 6 over root 6. This then gives us 12 root 6 over root 6 times root 6, which is equal to 6. Now we've removed the surd from the bottom line of the fraction. We can also go one step further here and cancel down here. This then gives us 2 root 6 as our final answer. So this is what we would call rationalising the denominator of a fraction. Let's have another go at a different question here. So we have 20 over root 5. 20 over root 5. We'll multiply that by root 5 over root 5. Root 5 over root 5 is just the same thing as 1, so it will not change the value of this fraction, but only how it is displayed. Now this then gives us 20 root 5 over, now root 5 times root 5 gives us 5. Again we can go one step further here and cancel these numbers down. 20 divided by the 5 then gives us 4. So that gives us 4 root 5 as our final answer. And this is rationalise the denominator of this fraction. Here we have another question here with a surd at the bottom line of the fraction. So again we want to try and rationalise this denominator and remove the surd from the bottom line. So let's have a go at this using the same method. So we have 1 over 2 plus root 2, and we're going to multiply that now by root 2 over root 2 to remove the surd from the bottom line of the fraction. This then gives us root 2 over root 2 upon 2 plus root 2. Now if we expand out the bottom, the brackets at the bottom line, this then gives us 2 root 2 plus, now here we have root 2 times root 2, which is the same thing as 2. So unfortunately this time, using the same method for this question here, it hasn't worked. We haven't been able to remove the surd from the bottom line of the fraction. We're going to have to take a different approach to these type of questions here. This time what we'll try and do is multiply the top and bottom line of this fraction by 2 plus root 2 instead, to see if this removes the surd from the bottom line of the fraction. So this then gives us 2 plus root 2 over 2 plus root 2 upon 2 plus root 2. So if we multiply out the brackets here at the bottom line of the fraction, hopefully this will remove the surd. So to multiply out the brackets, what I'll use here is the box method. Now there are a number of different ways you can use here, a number of different techniques and methods that you can use to expand the brackets like this. The one I will use here in this example is the box method. So I put one bracket here along the top and the other bracket along the side here, and I multiply each of the terms to fill out the box. So we've got 2 times 2, which gives us 4. 2 times root 2 is 2 root 2. 2 times root 2, which is 2 root 2 here. And here we have root 2 times root 2, which gives us 2 down here. Now if we collect the terms in this box then, that gives us 4 plus the 2. You've got a positive 4 and a positive 2, that's the same as 6. And here we have 2 root 2 and another root 2, so that's the same as 4 root 2. And our top line will stay the same there. So, as you'll see here, unfortunately, our method of multiplying by 2 plus root 2 over 2 plus root 2 hasn't worked here. We haven't been able to remove the surd here from the bottom line of the fraction. We're going to have to try something different. Now, this time we're going to try a different method. We're going to try and multiply the fraction top and bottom by 2 minus root 2 over 2 minus root 2. And hopefully this will remove the surd from the bottom line of the fraction. This then gives us 2 minus root 2, or the top of a fraction. And if we multiply the two bottom terms, this gives us 2 plus root 2 upon 2 minus root 2. So again, using the box method to multiply the brackets out here, we have one bracket along the top and the other one along the side here. Multiply each of the terms to fill out the box. So we have 2 times 2, which gives us 4. 2 times root 2, which is 2 root 2. 2 times minus root 2 is minus 2 root 2. And now we have root 2 times minus root 2, which is minus 2. So let's collect the terms here. Our top line is still going to be the same, 2 minus root 2. Now, collect the numbers, we've got 4, but then we're taking away 2, so that's going to be 2. We have 2 root 2, subtract 2 root 2. Now, they're going to cancel out then. So this then leaves us with 2 minus root 2 over 2. And we've successfully removed the surd from the bottom line of the fraction this time and rationalised the denominator. Feel free to pause now and try this one yourself using one of those methods. So we'll try the last method on this fraction now and multiply it by root 5 plus 1 over root 5 plus 1. This then gives us 4 upon root 5 plus 1 over root 5 minus 1 upon root 5 plus 1. So when you multiply out the top line, we get 4 root 5 plus 4. And if we multiply out the bottom line of the fractions using maybe the same method as before, the box method, this should give us 4. And we've successfully removed the surd from the bottom line of the fraction. We can actually go one step further here and divide each of the terms here by 4. So we've successfully rationalised the denominator of this fraction. Here we have a past paper question on rationalising the denominator. I want you to pause this video now and have a go at this yourself. So the goal is to remove the surd from the bottom line of the fraction. So the method that we should be using here is multiplying the fraction top and bottom by 1 plus 2 root 3 over 1 plus 2 root 3. And this should remove the surd from the bottom line of the fraction. So let's expand the brackets out here for the top line of the fraction using the box method. Multiply each of the terms here and fill in the box. So 5 times 1 is 5. 1 times root 3 is root 3. 5 times 2 root 3 is going to be 10 root 3. We've got root 3 times 2 root 3 is going to be 2 times 3, which is 6. Okay, let's do the same for the bottom line of the fraction here. We've got 1 minus 2 root 3 times 1 plus 2 root 3. And we're hoping here that we'll be left with no surd at the bottom of the fraction. 1 times 1 is 1. We've got minus 2 root 3 here. got 2 root 3. Yeah, so they're going to cancel out. And we've got minus 2 root 3 times 2 root 3, which is going to give us minus 2 times 2 times 2 times 3, which is going to give us 12. So you can then write this. Their top line of our fraction is going to be 11 plus 11 root 3. Because we collect the terms here, we've got plus 5 plus 6, which gives us 11, and then we've got root 3 plus 10 root 3, which gives us 11 root 3. Our bottom line for fraction will be 1 minus the 12, which is minus 11. As you see here, minus 2 root 3 plus 2 root 3, they're going to cancel out in the middle here. So we've successfully rationalized the denominator of this fraction. Now we can go one step further here and divide each of the terms by 11. This then gives us 1 plus root 3 over negative 1, which is really the same as minus 1 minus root 3. And that is the final answer for this question. Minus 1 minus root 3. Have a look at pages 11 to 13 in the SIA textbook and complete exercise 1F. I would also recommend Mr. Haggerty Maths videos on YouTube, and particularly the one titled Rationalising Surds.